Hi, this is Jeff Slarb. I've got an application here that I wrote. It is mostly written to showcase a new class that I wrote called JSCasterClass, and you can cast any type of, Clarion data types over any data buffer. So if you have a big string, then you can cast any kind of data like long, ulong, whatever, and even decimal types over this exact same buffer. So this allows you to do quite a few things. But right now I'm going to show you this DataScope app that I wrote using this class. So I'm going to open up a zip file here. And this list box on the left is with all the hex stuff. That's just a Clarion list box. I'll probably put a hex control on there, but we're going to be editing the data through a different means than the hex side. So I'm going to show you how to define a structure that you can use whenever you want to open this type of file. So we're going to do zip files now, so I'm just going to call this zip file header. And default offset, which starting at the beginning of the file will be 0. And I'll just say start.zip. And this is the name of the structure. And down here we can get down to the goodies. So I'm going to open up this web page that right here. I found it on Google, and it just happens to have a nice description of how the headers are laid out. So I'm going to go here to the first 4 bytes are taken up by signature, and I'll just call that a ulong because I don't really know how it's defined, but I'm going to just say that. And at offset 0, I'm going to put a ulong, and the name of this is called what? It is the signature. And there we go. And right now it's just showing as just a number, a decimal format. But if we wanted to look at that in hex, you could give it a special hex picture. And there it goes like that. And you can also edit that data as hex right here if you wanted to. So I'm going to add another field, and we want the version, and that's a 2 byte. I'll just call that a ulong or u short right there. And this is version, and that's 2.0. And then we're going to add the flags, which is a 2 byte, which I'm going to make it a u short again and say flags, and we'll make this binary, and there's no flags turned on with that, so it's not encrypted or anything like that. And our compression is also a 2 byte, so we're going to add u short, and that uses 8 is the deflate compression. I think they describe that here. Yeah, deflate right there. And then we want the modification time of the file inside the zip. So we're going to say, and this is at offset 10, and that was a 2 byte one. So I'll say that's a u short. But these are special. If you look at the notes here, it tells you that bits 0 through 4 are the seconds, 5 through 10 are the minutes, and 11 through 15 is the hour. So there's not really a data type that you can use to just say, I want just these bits. So we have to do special stuff here. And down here it shows even more a nice representation of it. So we're going to take the lastmost 5 bits here of a 16-bit integer here. So I'm going to make this a U short again. And this is going to be, I'll just call it time. And we are looking at, it's called the hours. And we want 5 of those bits, so we're looking at this as binary. But you can look at it however you want, at decimal or octal or hex. So we're going to make this 5 bits, so I'll say 1, 2, 3, 4, 5, and then the rest of them are all zeros. So then this is a 16-bit one, so I'll just give it 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then when we actually edit this data, it's going to have to be shifted over so we can get to it and be able to read it as English and stuff. So I'm going to shift this so that the ones are all the way to the right. So that means we have to shift it 11 times. And so if we save that, then we'll know that this is 19 hours, so that would be 7 o'clock p.m. And we're going to add another thing here, but we're going to stay on, you see that's offset 10. We're still looking at the same U short here, but we're going to look at different bits now. So we're going to say time minutes. And this one uses 6 bits. So we will say 1, 2, 3, 4, 5, 6, and then the rest of them is just 5. 1, 2, 3, 4, 5. And then we need to shift this over so that all the ones are to the right, and we'll go -5. So this is 7:41 p.m. because this is 1900 hours and 41. And now we can do the seconds. And still on offset 10 because it's the same variable. And we are going to say time seconds. And this is just 5 bits, which is also 31. So that means you can put a maximum value of 31 in this field. And it'll get naturally limited because of the bit mask that we have here. So this is the seconds, and really it's the seconds times 0.5. You just double it to get the actual seconds. And now we can add some additional fields here. We've got the time, and we're using the offset of 10, and we're looking at it 3 different ways with the different bit masks. And we've got to do the same thing with the date. So I'm going to add at position 12, U short, date, and this will be the year. And we've got a trash can in the background, but hopefully you can hear me. So we got the date, and we're only going to use the last 7 bits. So 1, 2, 3, 4, 5, 6, 7, and then we got to extend to 16, so I'll just add 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we want to be able to edit this data and view it in a way that we understand. We have to shift this so that the ones are all the way to the right when we're looking at it. So we're going to go to -9. And this says 20, but this year is actually the year minus 1980. So if you add 20 to that, to 1980, this means it's the year 2000. So we can verify that by looking inside our zip file, and I can see a bunch of 2000s here. I don't know what file we're looking at yet, but we'll know that in a second. So looks like we're good so far. And now I'm going to add the month, but we still want to be at position 12 because we're still on that same variable we're examining. And date, month, and this uses, I think, only 4 bits. So we'll go down to our little list here, and yep, just 4. And that needs to be shifted over 5. So I'm going to go back to my application and just give it 4 bits, 1, 2, 3, 4, and then add 5 zeros. And then this needs to be -5. Shift it over to the right, 5. So this is in June of the year 2000. And let's figure out what day it is. So then, same offset, we're going to look at U short and date, day, and this is only 5 bits, which is convenient because 5 bits has a maximum of 31, and we only ever have 31 days. So 1, 2, 3, 4, 5, which happens to be decimal 31. And we don't have to shift that because it's already right. So this is June 25th of the year 2000. So hopefully we've got, yep, we got some June 25ths in there. Okay, and the next field is just a CRC 32. So I'm going to enter a, you could use a long or a U-long. Longs are okay here. So I'm going to say long and CRC 32, and we'll look at it in hex. Ta-da! And now, what's our next field? File name length. Oh, no, it's compressed size. So that's a long, or I'll use a U-long there. 534 bytes is that one. And then the next one is uncompressed. So you can see that one was shrunk quite a bit. And then we have, I believe, the file name length. Yep, file name length, which is just a 2 byte. So the length of this file name is 25. And then this is special data length. This is usually doesn't have anything in it, but sometimes it does. And then I'll add at position 30 a string. And this is the actual file name. And since we already know that this is a 25 character length, I'll just say 25 here and just call it file name. This is going to change for all the files though. But you can see that the first file in this zip is called 16-bit ballad.mid. So now you can look at a zip file and find all the files this way. So all of the headers have this exact same signature here. You can see it has a PK at the beginning and then some gobbledygook, but all of the headers have this. So we can just find the next occurrence of this, and now you can see it's right here. So I'll go to the top one again, and you can see that the file name changed. So now we're looking at ballad 2, ballad 3. And you can do some pretty neat stuff with this. So if you wanted to go edit the hours, and there's only really, you can only limit it to 24 hours, but this data type, will go up to 31 because it's got 5 bits. So if I wanted to make it 32, it's going to say, nope, you can't do it because it's only 31. But we could make it 30. And now the hour is 30, which is totally meaningless, but I'm just showing you that we can do that and that kind of thing. So what if you wanted to just know where all of these zip records were? You can do a Control F to find it. And I'll just do a hex search because I can. And I'm going to say find hex. And as we find it, we're going to add it to our exploration history. And it'll just show us the offsets when we look at this. So we're looking for 504B0304. And the next one will be right here. And you can see it added it to our exploration history. And now we can go to that thing anytime. But now we can just press F3, and it's going to find us all the headers, and we can just scroll through them really easily. Even though the file name lengths won't always match what we have here for, it says 25, but you can still see it. I'm just going to hold F3 down and let it rip. And that's enough for now, but you can see that we can just scroll through a zip file without having to write an app to do it. And so you could use the caster class in there to easily just create runtime structures. And you could define these structures with an XML or whatever and tell it what data types you're looking at and find stuff that way. You can also just create a, if you like to look at certain data types that you're interested in, I'll just say this is testing. And we can add, just say you wanted to add look at a byte. We can see that this currently selected 50x or hex is the same as 80. Or if we wanted to look at this in binary, we can add it again. And we can still use offset 0. So we're looking at the exact same byte, but we can look at it a different way. So I will just say this byte binary. And we'll just say bin. And now we can see what bits are turned on. Well, and we can edit it that way. So if we wanted to change that to 81, there you go. I just made that. And if I set this to 1, that'll make it 83. Ta-da! So since they're both looking at the same data, it just reflects on each row here. And could do the same thing, bit 0 or offset 0, and then byte hex. And even though we already, so it's going to say 50, but I'll show you. Well, it's going to say 53 because we changed it. Got to refresh this. And now this shows 53. But if we want to change it back to 50, and I'll refresh that, and it shows 50. So then you can look at a different data type. You want to look at it as a short, no problem. Short, just regular. That's 843. You want to look at it in hex short, okay. Well, oops. Got to tell it what offset. We only wanted offset 0. And we'll make this offset 0 and short. And we'll make this So you're looking at, this is just the first byte, and then this is that byte and another byte. Pretty fun. If you wanted to if you want to get exotic here and say we're going to make a decimal, since as you can see, these hex numbers have letters in them, so they're not going to be too great for a decimal data type, but we can still do it. And I'll just give it a 13.3 in decimal. We don't have to name it, but I like to do that. So now if we go to edit the data, you can see that it's kind of weird because this underlying data doesn't really represent what a decimal would be, but we can change it. So we'll just say 1, 2, 3, 4, 5. Okay, now it's written. So now we look at the data here, and I'll refresh it, and you can see here is 1, 2, 3, 4, 5. So decimals are kind of different in how they do stuff. They store each digit inside a nibble. So it would be one hex digit goes up to 9. So it's 0 through 9, and then the remaining digits aren't used. So if you wanted to put a P string here, you could make it. P strings are weird because if you have an invalid length, then it looks weird, but you can still initialize it after you set it. So right now it's just nothing. So we'll go into it, and this is a test, and you should see, oh, wait a second, make this offset 0. So then I'll say this is a test, and you should see a new number on byte to show the length that this string is. So that's a 14 length byte, because the first byte of a P string is the length. So right here is 14 is the length. But so if we change this to add a period there, it's going to say 15. Interesting to see the underlying stuff. So now this is an F, because this is 15.
Bop, bop, boo, bop, bop, bop.